Okay, fine. Right. Before we start, one more announcement regarding the quiz. I saw a couple of members have sent the quiz answers to my email. That's not the procedure. So that you should send the answers to the chat box, right? If you miss it within the time to submit, that is up to you. So that any quizzes that has been sent to my email ID will not be considered for marking purpose because it is a time-bound quiz now. So, therefore, this will not be marked. Anyhow, the second information is you type the answers in the chat box. Do not attach any pages, right? So that is quite important. Yeah, recordings, Kauder. Somebody is asking recordings. It is there. Recordings have been already uploaded with the Google Drive. If you have missed it, that I don't know, because every time we upload the recordings. I think we have already uploaded the recordings. Tutorial, you don't need. That is only for your benefit. Right? You can work it and see whether you have done correctly and so on. I'm not going to discuss any tutorial here. We don't have time. So it is for your practice, the tutorial, not for discussion. Let me check with the system analyst to see whether he has uploaded the Google. Yes. Can everyone see the Google material here? Download materials. Yeah. එහෙමජිත් මේ අපේ recordings upload කරනවා නේ regularly. Google එක අදත් පොඩ්ඩක් දාන්න මේ ළමයි ආනවා. අදත් share කරනවා. Okay. So don't ask this question every day because this is a third lecture that we are third time we are meeting. So that every day don't ask the recordings because it is already uploaded to the Google, right? Right. Do all quizzes considered to the exam? That means all quizzes will be marked. At the very first day, I said quizzes will be marked and 40% marks will be taken from the quizzes. At very first day, I announced this, right? So quizzes will be marked and will be evaluated, right? So that it will be considered for the final marks. Okay, final marks. Yeah. Right. So you type the answers in the chat box. Do not attach any pages. If you attach any pages, you will be disqualified. One more announce. Type only one time. This is for the quiz. Type only one time to submit the answer. For the quizzes, you type only one time to submit the answer, because if you look at the quiz answers, one person has typed 3 times. So which one is we consider correct? Which one is wrong? So if you have typed more than once, that will be disqualified, right? Type only once. Make sure that your answer is correct, then you submit, right? So the answers are usually in a simple form. We'll be able to type it on the chat box. That is how I give the answer. So we need the final answer, not the process or the procedure of the how you got the answer. We don't need that. So the answer, final answer, you can give it values or equations, etc. Right. We will continue from yesterday. We were talking about limits. All right. We will be we are talking about limits, and we tried to solve some of the limits yesterday. We took some couple of examples to solve the limits. Right. Now, in the same line, where I'm going to show you different ways of solving or finding the limits, right? Another example, find out the limit of a function x square minus 9 divided by x square minus x minus 6, where x reaches 3. Another example. Can you find out the answer? Find out the limit of the function x square minus 9 divided by x square minus x minus 6 when x reaches 3. Can somebody give an answer for this? What is the answer? Sachini, what is the answer? Prasadi, what is the answer? Anyone?
0.
0, okay. Any more answer?
It's 6 by 5.
Pardon?
6 by 5.
6 by 5. Yeah. Any other answers? Any other answers?
1.
Right. Yeah.
1, sir.
Yes. What is the answer?
1.
Any other answer than what people have suggested?
1.
Huh?
1. 1.
I don't hear. I don't hear clearly. You can put it in chat box if you are not sure.
0, sir.
0. Okay. People have already suggested 0. Somebody said 1. Yeah. You said undefined. Undefined, you'll have to come to a defined version. Right? Any suggestions? Any suggestions? Yeah, you can work it out. Let's look at it. So simply, if you ask to find out the limits, you submit the value which is given for x for the variable. So here we can solve this. 3 square minus 9 divided by 3 square minus 3 minus 6. So what is that? That is equal. The numerator is 9 by 9 minus 9. Denominator is 9 minus 3 minus 6. So that is equal. Numerator is 0, whereas denominator is 0. 0 divided by 0. So sometimes people write it as again 0. Maybe in earlier cases you might have come across like that. But that is not a proper way. So this is called as no solution. No solution, because the reason is we are dividing 0. 0 is not a natural number, right? By another 0, right? 0 means null. So can you divide a null by another null? Logically, you cannot. You cannot divide a null by another null, right? Therefore, this is undefined. We call it as no solution and undefined. Therefore, we have to find some other way to solve this. How we can solve this? You see here, this is a quadratic equation, isn't it? We can factorize this. This is where we are going to use our factorization process, which you have learned in your first day. So when you factorize, how we can factorize this component as x minus 3 into x plus 3. That is the denominator, divided by x minus 3 into x plus 2. So don't ask how we do the factorization. I have given enough examples in the tutorial also to practice again, right? Now we can cancel off some of those. Then we can, now our new formula or new function is x plus 3 divided by x plus 2. So now we find the limit of that function under the same condition where x reaches 3. So that is equal 3 plus 3 divided by 3 plus 2. So the answer would be 6 by 5. So you could see how far deviation is from 0 to 6 by 5. So the answer is 6 by 5. Right? Any questions? So I'm showing different pathways to solve the limit functions. So this is one way. Another example, try this one. Find out the limit of a function x squared plus 2 divided by 2x squared plus 1 when x reaches 0. Can you find out the value? Very simple. Anyone answer?
Two.
Any value other than 2?
So it's
So
2.
this is 0, right? 0 square, that is 0 plus 2 divided by, again, 2 into 0 is 0 plus 1. So that is equal to. Okay? Right. Further, I have given plenty of examples in tutorial. You can try those, right? But we will have a couple of more examples because some of the limits you can solve using one technique, one particular technique. You cannot use all techniques to one particular limit to solve, right? Therefore, I am showing another one. Try this one. Limit of a function 1 minus into 1 minus x whole thing to the power half divided by x, where x reaches 0. X reaches 0. What is the answer?
Infinity.
Infinity. Why infinity?
When the number cannot divide by 0,
Huh?
it reaches to infinity.
What is the value coming here as a numerator?
1.
1. Are you sure? What is the denominator?
0.
0. Anybody getting a similar answer?
0.5.
Sir, 1.
Pardon?
1.
0.5.
1. Better to give in terms of numerator and the denominator. What is the numerator? What is the denominator?
0 by 0.
0 by 0. Any other answers? This is the second answer. Any other answer?
0.5.
Yeah, but you give me the numerator and the denominator.
0.5 divided by 0.
Pardon?
0.5 divided by 0.
5 divided by 0. Okay.
0.5.
Any other? Yeah.
0.5 divided by 0.
Okay. Any other answers?
So half 1 over 2.
Okay. 1 over 2.
1 over 2, sir.
Okay. Any other answer?
1 over 10.
1 over 10. I'm asking the first choice. I mean, the first time. I mean, once you substitute value 0, what will be the stored? Right. We will see that. Right. I'll use another color pen. Right. So this is once you submit 0, 1 minus into 1 minus 0 whole things to the power half divided by 0. Am I right? So that is equal. Here, numerator 1 minus. Here 1 minus 0 is 1. Okay. 1 to the power half. What is 1 to the power half? Divided by 0. Anybody, what is 1 to the power half?
1.
1. Yes. So 1 minus 1 divided by 0. So that is equal 0 divided by 0. Similar case as earlier, isn't it? 0 divided by 0. So already I mentioned null divided by another null, no solution. Then what to do? You see here, we have a power half that we need to get rid of it to solve it. To get rid of this power half, where we can multiply the same equation by another plus 4. So this is my equation, right? Where I'm going to multiply equation of the function, where I'm going to multiply by a positive sign here, 1 plus into 1 minus x, whole thing to the power half. When you multiply the numerator, you have to multiply the denominator also. You cannot multiply only the numerator because the property might change if you multiply only one component. So that multiply by the same component of the denominator, right? When you multiply these two, it becomes as 1 minus into 1 minus x. This to the power half will get rid of it, right? Whole thing divided by x into 1 plus into 1 minus x, whole thing to the power half. So this is how it works. Further, if you solve it, right, this will become as, right, here this minus will become minus, right? So this 1 will cancel off. So we will end up with x divided by x into 1 plus into 1 minus x, whole thing to the power half. So this x will cancel off again. So you will end up with 1 over 1 plus into 1 minus x to the power half. Now you can apply the limit. The limit conditions will be same where x reaches 0. X reaches 0. So again, that is equal. You can rewrite it as 1 over. What is the answer? 1 over 1 plus, right? 1 minus x to the power half, which become as 1. So the final answer would be half. Final answer would be half. Any questions? Right. Take another example. Find out the limit of the function x square plus 2 whole thing divided by 2x square plus 1, where x reaches infinity. X reaches infinity. What is the answer? Yeah, anybody? What is the answer?
Sir,
Divide by 2.
previous question.
Huh?
1 divide by 2.
1 divided by 2. Let's see the answer later. 1 divided by 2 is one of the answer. Any other answer?
1.
1. Any other answer?
Zero.
Okay. Yeah. How do you get 1? Better to give in terms of numerator and the denominator. What is on the top, what is on the bottom? Those, the person who said 1, what is numerator, what is denominator? How do you get 1? What is on top, what is on bottom? Tell in fraction. Opening
Infinitive and infinitive.
infinity.
Over infinitive.
Infinity
Over infinitive.
over infinity. Okay. So that you are getting 1. Fine. Any other answer? Somebody got 0. How 0 comes?
So infinite by the upon infinite.
Infinity divided by infinity.
Yeah.
How come you get 0 infinity? When you divide 5 by 5, you will get 1. Infinity divided by infinity, how do you get 0? You understand my question? Yeah, right. We will see the answer. Yes. You see x is infinity, so infinity plus 2 divided by 2 into infinity is infinity plus 2. So infinity plus 2 is infinity divided by infinity plus 1 is again infinity. Right? Okay? Right. What is this? We spoke about this yesterday, isn't it? Infinity divided by infinity. Infinity is an undefined value, is it? It's a undefined value. So you undefined value divided by another undefined value. So here we can't solve through this. No solution. We can't solve this. No solution. So we'll have to find some other way to get the answer. Right. The same equation. Under the same equation, we are going to assume certain other things. What are the assumptions that we want to take it? I'm going to introduce a term called as t, which is 1 over x. T is 1 over x. Right? So that I'm going to introduce another variable t, so that when x reaches infinity, right, we have t that also reaches 0. So basically what we try to say is, whatever the variable that we are assuming is not considered, it's a null, right? So this is another example that we could do it, right? Okay. So that when we consider x reaches infinity, so t also reaches 0. So we can talk about now, we can find out the limit under the condition where t reaches 0, because x, when x reaches infinity, t reaches 0. So we are now converting into t, so that we are converting our whole formula into t terms. So 1 over t square plus 2. We are substituting instead of x, 2 divided by t square plus 1 equal, right? Here we can expand it again, limit where t reaches 0, right? We could say 1 over t square plus, right? Or we could say, we can take the t square as a common term. T square is a common term. 1 plus 2t square. Whole thing divided by 2 plus t square by t square. So we can cancel off this t square and this t square. So we will end up with a value 1 plus 2t square divided by 2 plus t square. Now you find the limit when t reaches 0. You find the limit when t reaches 0. So that is equal 1 plus 0 divided by 2 plus 0, which is 1. Right. I will show you one more example. Right. So different forms. Another example. Find out the limit of a function is given as square root of x square plus 1 minus x when x reaches infinity. When x reaches infinity. Can you find out the answer? You simply substitute the value for x as infinity. So this will end up with infinity minus infinity. Infinity minus infinity. What is this? Infinity minus infinity. Is it 0 or can we say infinity minus infinity is equal 0? Yes or no? Infinity minus infinity is 0. Can we say like that?
No.
No, we cannot. Because infinity is undefined, as I said earlier. So one undefined minus another undefined, no solution. So what should we do? Then we try to find out using another technique to solve this problem, right? Again, similar to the earlier one. So I can say x square root of x square plus 1 minus x, where I'm going to multiply. This can be given as or written as the square root of x square plus 1 minus x, right? Where I'm going to multiply by a plus component, right? Square root of x square plus 1 plus x, right? Divided by same x square plus 1 plus x. Because here we'll have to multiply by the same component to the numerator and the denominator. Here, even though we don't say, there's a denominator, which is 1. So we'll have to multiply the same component above and below. Right? Once you multiply, you will end up with so many people are making noises. Why don't you mute it? You have to go and mute it manually one by one. So you better mute it. Right. So here you multiply by a plus component to the numerator and the denominator. So you will end up with x square plus 1 minus x square divided by square root of x square plus 1 minus x, plus x, right? So here this x square cancel off. So we will end up with 1 over right? You end up with 1 over, right? Square root of x square plus 1 plus x. So this is your final situation. Now you apply the limit when x reaches infinity, right? That is equal 1 over infinity plus infinity. What is 1 over infinity plus infinity? So we know that 1 over infinity plus infinity is 1 over infinity. So that is equal to 0. That is equal to 0. Right. Any questions? We can come to a situation, no solution, under 0 divided by 0. This is no solution, right? Infinity divided by infinity, right? Infinity minus infinity. What about infinity plus infinity? Is it a no solution?
Again, infinity.
Pardon?
Again, it's a infinity.
Yes, it is infinity. Infinity plus infinity is infinity. So here we can't say no solution. Infinity plus infinity is infinity, right? Infinity minus infinity is no solution. Infinity divided by infinity. Infinity divided by 0. Or 8 divided by 0. Zero divided by 5. These are practical questions. What is 0 divided by 5?
0.
0, yes. What is 8 divided by 0?
Infinite.
Huh? 8 divided by 0.
0.
8 divided by 0. Anyone?
No solution.
Huh? 8 divided by 0?
Infinity.
Infinity, yes.
Infinity.
Infinity. Right? Okay. So that if 8 divided by 0 is infinity, infinity divided by 0 is, that is also infinity. Right? Okay. Right. That's all for the limits. We have plenty of examples in the tutorial. You can try them. All these. You can solve those questions either by one of these technique. We have used several techniques, right? So one of the technique will be suitable to solve one of the, at least one of the limits in the tutorial.
So, excuse me, sir.
Yeah.
When 1 divided by infinity equal is 0, so can we put it as 0 in this?
1 divided by infinity.
Equal to 0.
Hmm.
So can we keep this as 0 if it's as a null value in our equation?
I didn't understand the question. 1 divided by infinity is
Equal
0.
0 in previous one.
Yeah.
Can we keep this as 0?
This is
when
0. Yes. Yeah. 0 is possible. Answer could be 0.
Yeah, okay. Thank you, sir.
So this is the fraction. So after the fraction only we get the 0 value. This is not the 0 divided by 0.
Yeah, okay, so thanks.
Yeah. So this answer is correct. Because we got the 0, true 0. Because 1 divided by infinity is 0.00000 and so on, right? So that is equal to 0. Right. Today we are going to move to the main portion that is called as calculus, right? A lot of applications are there in the calculus, right? It could be agriculture, it could be science, it could be engineering, it could be any field, medicine. A lot of applications are there in the field of any field, any discipline. So calculus is very important. So under the calculus, there are two main parts. One is called as differentiation, other one is called as integration. Today we are going to look at it, differentiation. Differentiation. Right. Before we talk about differentiation, right? Let's take a growth curve. It could be either growth of an animal or growth of a plant, doesn't matter. Anyhow, I will take growth of a plant. Any plant. Growth of a plant. Let's say we are considering height with the age or time. How the graphs look like, how the curve look like. Is it a continuous, first of all? Is it a growth of a plant? Is it a continuous? Or height of a plant, is it continuous with the age or time? Or discontinuous, yeah? Continuous, right? So normally, growth of a plant, by definition, we call it as sigmoid curve. It's like S-shape, right? Sigmoid curve, you might have studied earlier. When you talk about this particular sigmoid curve, right? So slope, let's say I take a particular time period. At that time period, my height is, let's say, h1, time is t1. Okay? At another time, another time, t2, h2. At another point, T3 H3. T3 H3. When you talk about this growth curve, what do you think about this particular growth curve? How about slope? Does the slope same in all the positions of the time? At all the time, does the slope same or different?
Different.
Different. So we
It should
could
be
say
different.
slope is varies, right, along the curve. Do you all agree with that? Slope is vary along the curve. Okay.
Yes.
For example, if it is a straight line, what do you think about the slope of the straight line? Is it same at any level of x?
Yes.
Yes, at any level of x, whether it is here, whether it is here, whether it is here, the slope is same. So that is why it's called as linear. Slope is same at any point. This kind of curve is called as non-linear. Maybe we will be touch upon this concept, maybe in statistics, right? Maybe at the last sessions, you will be discussing about regression. So under that, you will be learning little on this. Okay, what is the meaning of linear and non-linear? Right. This is a non-linear, therefore the slope is varying along the curve. Along the curve, slope is varying. Okay. Right. Now, how does the slope varies along the curve? Right. For example, if I want to measure the average height growth between, let's say this is point O, point A, point B, and point C. The average height growth between O and A, where we give it as R1, average height growth between, right, O and A. It is the it is defined by R1. It is defined as an increase in height between O and A divided by the time taken between O and A. Okay, time taken between O and A. So that we could write it as the time taken between O and A is, the height increase in between O and A is H1 divided by the time taken between O and A is T1. H1 divided by T1. Similarly, if I want to find out average height growth between A and B, then we could say R2 is equal, in simple form, we could say the change in height between A and B, which is H2 minus H1 divided by the time taken between H2 and H1. That is T2 minus T1. Likewise, if I want to find out the height growth, average height growth between B and C, Again, I could write it as H3 minus H2 divided by T3 minus T2. Can I write like this? Yes or no? Anyone? Can I write like this? Nipunika? Can we write like this? Or you are keeping silent?
No, we
So
need
this-
to.
Yes,
Yes.
sir.
Yes. So we have this R1, R2, R3, different growth rates, right? Are they similar? Or are they different?
Different.
They are different. They are different. Right? They are different. So this is actually the slope. Basically, we measure the slope between average slope, huh? Because we are measuring the average slope between O and A. This is average slope between A and B. This is the average slope between B and C. Right? So these slopes are not equal. Okay? So we are going to use this differentiation concept in most of the growth functions, because that is mainly the application. So you might wonder why we are learning mathematics, what is the use of it? Yes, there are a lot of application. We will come to that later, right? Directly the applications. Before that, we need to learn a little on how to differentiate the function. Then we can see the applications. Therefore, this differentiation can be defined as concept of differentiation. Concept of differentiation is the rate of change in quantity. Rate of, it is the rate of change in quantity. Okay? Concept of differentiation is the rate of change in quantity. Don't forget that. Rate of change in quantity. Okay? Fine. Any questions? Right. Let's look at derivatives. What is this derivatives? Right? Actually, derivatives, if you take a function, if you do a process called as differentiation, the product of this differentiation is called as derivatives. Okay? So differentiation is the function or process. The derivative is the product. If you differentiate a function, it will produce the derivative through the process called as differentiation. So derivative means it is the product. Okay? How we can further define this product derivative? For that, we have a graph. right? Here we have x-axis and the y-axis. Let's say I have a curve, okay, non-linear one. I take a point here. Right, point there. That point we could say P, take a point P. Their coordinates are x0 and y0. Take another point Q. Their coordinates are, right, x0 plus h and y0 plus k. So this is, we know that this is obviously k. This is obviously h. Do you all agree? Yes. Right. Now, if you look at the growth rate here, if you talk about growth rate, right? If you look at this graph here, the average rate of change of y between 2 points P, which is having a coordinate of x0 and y0, and Q, x0 plus h and y0 plus k, is R, where R has been defined as the increase in the value of y between P and Q divided by increase in the value of x between P and Q. So that is equal y0 plus k divided by x0 plus h. Y0 plus k, that is the upper point, minus y0 divided by x0 plus h minus x. So that is equal to k divided by h, right? K divided by h. Yeah, here I missed one more thing. Here, this is a function where we could say it as y is the function of x, which is a continuous function. Only for continuous function, we could talk about this differentiation. Okay. It's a continuous functions, assumed to be a continuous functions where y is equal fx. Right. Now, once you come to here, we already know y is equal fx. This is the function. So we can write that y0 is equal f x naught. Similarly, we could write it as y naught plus k is equal f x naught plus h. Isn't it? Because these are, I mean, at any points on the curve, the relationship is like this, any points in the curve. So this is the general term. So this is one point on the curve. This is another point on the curve, right? So we could write our rate of change as r is equal function of x naught plus h instead of y naught plus k minus function of x naught, whole thing divided by h. So we could say, we can write this in a general term. So r is equal limit of the function of x plus h in a general term minus function of x, whole thing divided by h, where h reaches 0. Right? Little on theory. So here we can consider a delta is the rate of change. We have delta x and delta y. So we could say, if you take the limit of a function fx plus delta x minus fx divided by delta x when delta x reaches 0. So that is actually r, where it is defined as delta y by delta x. Small change in y divided by small change in x. So this, if you take the limit of this delta y by delta x, when delta x reaches 0, then that is called as derivative. So this is called as derivative. So derivative, as I mentioned earlier, it's a product of a function. So we symbolically say as f dash x. So that is the derivative. This is a derivative. This is a function. Derivative of a function could be obtained using the process called as differentiation. Differentiation. Okay. Right. So little on theory. So everybody need a bit of theory also along with that. So that is about the theory. Right. Now for a given function, we can find out the derivative. How to find out the derivative. Right. Derivative has to be found out through first principle. We are going to find out the derivative through first principle. I will take an example. Y is a function of x is equal 5x square plus x. 5x square plus x. Right, this is my function. So you can write this as y equal 5x square plus x, same thing. A small addition in x, that is 5x plus delta x square plus x plus delta x. Here I am adding a small quantity in x, will also have a change in y. So can you remember earlier we said a small quantity addition in x will change a small quantity in y also. You have a small change in input, in the output also you will have a small change. Right? Right. Now, what is our limit? Before limit, we need to get the delta y by delta x. To get the delta y by delta x, we could say y plus delta y minus y divided by delta x. So that we can substitute using our information. Y plus delta y is equal to 5 into x plus delta x whole thing square plus x plus delta x, right? Minus, what is y? Y is here. I'll put it in a bracket. 5x square plus x. I'll put it in a bracket. Okay? Clear? Whole thing divided by delta x. Before we take the limit, we will find out the delta y by delta x. Now we'll have to expand it. How to expand it? Right? 5 is already there. X square plus 2x delta x or plus delta x square. That is one component. Second, x plus delta x minus 5x square minus x. We can expand this 5x square plus 10x delta x plus 5 delta x square plus x plus delta x minus 5x square minus x. Now we'll have to cancel off certain things. This will cancel off. This will cancel off. Right? I forgot to give the denominator. Delta x denominator is always there. Right? Once you cancel off, you will end up with 10x delta x plus 5 delta x square plus delta x. Whole thing divided by delta x. Right? So here we have a common term of delta x, so that here I can cancel off 1 delta x here and here. So it will be ending up with as 10 x plus 5 delta x plus 1. Whole thing divided, whole thing, yeah, that's all. The denominator is also cancelled. So this is my delta y by delta x. Now you find the limit when delta x reaches 0. That is equal 10x plus 5 into delta x, which is 0 plus 1. So the answer would be 10x plus 1. So this is my derivative. Derivative is given as f dash x. Right, I'll take one more example, one or two more example. Try this one. Can you find out the derivative of this using the first principle in a similar way?
Sir,
Yeah,
sir, in the previous step, how can we know that delta x reaches 0?
no, that is the function of limit. Here, that is a condition, right? So this is how the derivative has been defined. So delta x should be reaching 0 to find out the derivative of the delta y by delta x. Okay. So under the assumption of that, then you take limit. Always this is how the delta x has to be 0. Okay. Clear? Can you try the second one? I will bring a cup of, glass of water. I will come in a minute. Try this one and get the answer. If you have answer, put it on the chat. I will come with that water. Anybody got the answer? Through the same concept. So how we can write this? This is x plus delta x. If you add a small change in x, which also reflect in y. So this is the first step. Second step, delta y by delta x, which is y plus delta y minus y divided by delta x. Right? So that is equal. We could write x plus delta x whole thing to the power half minus x to the power half divided by delta x. Right? Now how to solve this? Now we want to get the limit of this. Can you remember in if the power comes, how to solve in limits. What did we do? What did we do in limits to solve the powers? We multiplied by a positive component, isn't it? X plus delta x to the power half plus x to the power half divided by the same component, because we'll have to multiply by the same component. Much of brackets, right? So we are multiplying by a positive component. So if you multiply, you will end up with, I'll write it here, you end up with x plus delta x minus x whole thing divided by delta x into x plus delta x whole thing to the power half plus x to the power half. Okay. All right. So here we can cancel off this x and this x. Once you cancel off, you can cancel off this delta and this delta. You will end up with 1 over x plus delta x whole thing to the power half plus x to the power half. Any questions? Any doubts? Any questions? Any doubts? Any clarifications? Right. Okay. So now we can apply the limit, right? So we can apply the limit. Limit to the 1 over x plus delta x whole thing to the power half plus x to the power half, right? So if you apply the limit where delta x reaches 0, then this is becoming as 0, right? So you will end up with 1 over x to the power half plus 1 over x to the power half. So that is equal 1 over 2x to the power half. So that is my answer. We'll do one more and complete it. Another example. Y equal 1 over x. So this is the derivative of the function given up. Okay. So y plus delta y is equal 1 over x plus delta x. So in a similar way, we could say delta y by delta x, which is equal y plus delta y minus y divided by delta. So that is equal 1 over x plus delta x minus 1 over x divided by delta x. Again, the same concept. All right. We multiply by a positive component, right? if you multiply by a positive component, or we can do it in earlier way, or we can do it slightly a different way. So here we could say we take the delta x out of it, 1 over delta x is out of it, right? Then we try to solve this, right? Taking the common term. So we could say x plus delta x, right, minus 1 over x, sorry, x, okay, x plus delta x minus yeah, sorry, I did it the other way around. Just a second. The components have to be alternative. X minus x plus delta x. This is how it has to be, right? When you take the common term, divide by delta x. Okay? Divide by delta x into x plus delta x. Okay? Right. Now we can solve further. This x will cancel off with this x, minus and plus. And we will end up with minus delta x divided by here. So write it here. 1 over delta x is there into minus delta x, whole thing divided by x into x plus delta x. So that is equal. Here again we can cancel out this, become as minus 1 over x into x plus delta x. Right? Now you can apply the limit to the function minus 1 over x into x plus delta x. When delta x reaches C. So that is equal minus 1 over x square minus 1 over x square. So that is the answer. Any clarification before we move further?
Sir, can you go to the previous question, please?
This one.
Yeah, sir, the answer isn't the answer should be 2 over x square root?
2.
2 over x
Which
square
one?
root.
The final answer?
Yeah, fine.
You mean this one?
Yes, sir.
Why? Because here we are adding 2 x to the power half, isn't it? We are adding 2x to the power half. So it is
Oh, okay, sir. Okay, it's fine.
we are adding this.
Yeah.
Right? So it's like yeah, we are adding this addition. 2 times of x to the power half. Okay. Right. Any questions further? Because it's a long process, isn't it? finding out your derivative from a function, right? We have seen it's a long process. Suppose, let's say, if I have a function right, then your components will be more complicated. 3 into x plus delta x to the power 3 plus 4 into x plus delta x to the power 2 plus 8 into the x plus delta x plus 9. You see how big is this? When you multiply 3 times, 2 times, right, it becomes very big, more complicated. So what to do? There are shortcuts, right? Shortcuts to find out the derivatives. Even though it is shortcuts, it's coming under the rules. So you follow the rules. What are the rules? How to follow the rules? What are the rules? How to follow the rules? Let's look at the rules. First rule. Don't forget, these rules are very important. All these rules are interlinked. One, without these rules, you cannot solve the derivative. I mean, you cannot find out the differentiation. Derivative of a function. Right. So what is the right? What are the rules? Derivative of a constant is right. What do you mean by graphically? If you show, what do you mean by derivative of a constant? Here we are talking about two variables, x variable and y variable. So another term, y is equal c. C is a constant. Or we can say y is equal fx, function of x. C is a constant. So that means here there's no any variable involved. If you look at the graph, it goes like this, right? Almost parallel to the x-axis. Even though x value increases, y value does not increase. Even though x value increases, y value does not increase. So what is the derivative of a constant, right? So what is the concept behind the derivative? Delta y by delta x z. Delta x means the change in x. Delta y, does the change in delta y occurs? What is the delta y here? In this example, when the x change from one position, let's say x1 to x5.
0.
Yes. When it moves from x1 to x2, there's a change in x. But what about the change in y? Change in y is 0. So any value, or 0 divided by any value, is equal 0 because it has a value. You are definitely x1 from x1 to x1, if it is moves, there's a value, right? But delta y doesn't have a value. So 0 divided by a value. What is that?
0.
0. So derivative of a constant is 0. So that is your first rule. So derivative, this delta y by delta x also can be said as dy by dx. Hereafter I will be using dy by dx. Small change in y divided by small change in x. Clear? Right. Any questions? That is my first rule. Right? That is our first rule. Not my, it is the first rule. Second rule, derivative of x to the power n. Derivative of x to the power n. Let's say function of x is given as x to the power n. Right? Then my derivative dy by dx is given as n into x to the power n. So this is the second rule. Dy by dx, which is actually the derivative, is given as n into x to the power n minus 1. My n and x are looks like similar, but if you have any doubt, ask me. Yeah? This is n, this is x. There's a difference, but if you have any problem, let me know. Right. Let's take an example on that. Let's say a function of x is equal x to the power 5.
Excuse me, sir.
Yeah,
Sir, what is the difference between dy and delta y?
same. Small change in x, small change in y. Dy by dx, derivatives. So usually we use dy by dx or delta y by delta x. Same, more or less. No difference.
Thank you, sir.
Small
Thank you,
change in y divided by small change in x. So this is equal to dy by dx. Right? Here, normally, when you have, here we are dealing with only two variables. One is y variable, the other one is x variable. When you're dealing with two variables, we use differences in y divided by differences in x. But when you have three variables, as an example, later we will talk about this at the end. Suppose here we have three variables, z, x, and y. So in this case, usually we use delta. Delta z, delta x, delta y. So, but the initial form is delta. Delta indicate the rate of change, small change, right? Rate of change, small rate of change. Right, x to the power 5. So everybody knows here n is 5. So fit into that formula. So my derivative or dy by dx is equal 5 into x to the power 5 minus 1. So that is equal 5 into x to the power Very simple. Right, next rule. Rule goes like this.
Sir,
Yeah,
in the limits example, what happens when it is multiplied by the positive component?
I didn't get it.
So in the previous limit example,
Mhm.
at one time you multiplied the denominator and numerator by the positive component.
Yeah, that is to get rid of that powers. Right? To get rid of powers. When you have, let's say, x plus delta x to the power half minus x to the power half as an example, right? Right, as an example, right? So here, if you write it this is actually this format, isn't it? Am I right? This is the format. Okay, we can write either this way or that way. So to get rid of this, we multiply by a positive terms so that they will cancel off. The powers will cancel off. When you add, right, you can see. So that is why we multiply by a positive term to get rid of the powers. Okay, because when you have powers, sometimes very difficult to work it because these are fractional powers. The full number powers, we don't have that much of problem. X plus delta x to the power 3. So this is not a very big problem. But if you come to the fractions, like 1 by 3 or 2 by 3 or half, then difficult, right? Even getting the value is difficult, isn't it? For example, 3 plus 4 to the power 1/4. We'll have to calculate it, isn't it? 1/4 or 1/3 or whatever it is, we'll have to calculate. So that is why we use it in mathematics to get rid of that. You multiply by a plus term. When you multiply by a plus term, you'll have to multiply in both cases. Not only one, in both cases. Numerator as well as denominator. Right. The next rule, right? If you have a function, so c is a constant into x to the power n, the derivative dy by dx or f dash x can be given as n into c into x to the power n minus 1. So this is next rule. Okay. N into c into x to the power n minus 1. So what is that? So let's look at this one. Y is equal 3x to the power 4. So here c is 3, n is 4. So dy by dx. Everybody understand this concept. Later you will be in trouble, huh? Because this is the initial point, starting point of differentiation. Once you go through the pathway, you will go through a very difficult pathway, finding more and more complicated rules. So these are very easy rules. If you don't understand, you'll be in trouble. So everyone understand well. If you have any doubt, problems, ask me. Right. So here n is 4 into c is 3 into x to the power 4 minus 1. So that is equal 12 into x to the power 3. Clear? Is it clear to everyone? Why don't you respond?
Yes.
Yeah.
Yes, sir.
Right. Good. Then the rules continue. This is next rule. If you have a function y which has been splitted into two components, suppose let's say u and v, then the derivative of that function dy by dx is given as you differentiate them separately, which is called as du by dx into dv by dx. So this is the next rule. Right? That is the next rule. So what we are doing is, this is the function y is equal to u plus o minus v. If you differentiate y with respect to x, so this is called as differentiating y with respect to x. We always differentiate y with respect to x. Here we don't have any problem. Here we have only one independent variable, that is x. So we always differentiate with respect to x. So we call it as differentiate y with respect to x. If you differentiate y with respect to x, here we have two components partition. So first you differentiate u component with respect to x plus or minus. Then you differentiate a v component with respect to x. So that is called as du by dx plus or minus dv by dx. Take an example. So this is the same kind of example. So plus, you see. So one, this is u, this is v. Right? How to differentiate? You differentiate them separately, because already I said you differentiate them separately with respect to u as well as, with respect to x, right? You differentiate u with respect to x as well as you differentiate v with respect to x. So we could say dy by dx, I differentiate first this component, use the rule there, 3 into 2 into x to the power 2 minus 1 plus 4 into 1 into x to the power 1 minus 1. That is equal 6x to the power 1 plus 4x to the power 0. Then what is the answer? 6x plus 4 into x to the power 0 is 1. Good. So I can write it as it is. So this is my answer. Okay. Any questions, doubt? In tutorial, you have plenty of examples you can try later on. I will not talking about much of the examples, but still you can try. Any questions? Right. Let's move to next rule. I couldn't remember what is the number, but next rule. Suppose if you have a function which split it into u and v component, which are multiplying, then what to do? Then dy by dx is given as u into dv by dx plus v into du by dx. U into dv by dx plus v into du by dx. Right? Take an example. Y equal x square plus 1 into 3x plus 4. We can do it in two ways. One is we can multiply these two components. It's not a big deal multiplying. We can multiply this component and do the differentiation. Or we can follow the rule here. So this is a u component, right? This is a v component. So dy by dx, right? For easiness, what we could do is we can identify u and v initially. Then we can make a note of it. What is u, what is v? Then you differentiate them first. So du by dx is equal to 2x. Right. I didn't mention some more thing. Right. One thing before that we will do an example. Y is equal 3x square plus 8. What is the derivative of that? Anyone? Let us apply the rules. Here the first rule comes.
6.
Third rule comes. Yeah.
6x plus 8.
Yeah.
6x.
Right. Let's look at here. 3 into 2 into x to the power 2 minus 1 plus. What is the derivative of 8? First rule.
0.
Yeah, it is coming as a constant. So if you say plus or minus, then you'll have to differentiate, then separate. Right? When you look at them, if there's no variable involved, it is not 8x, it is just 8 number. Number is a constant. So what is the derivative of a constant? What we have already learned from the first rule? It is 0. So the answer is 6x. Similarly, what is the derivative of, in this case, u? 2x plus 0, isn't it? So that it is 2x. So the derivative of v is given as 3. Derivative of v is, anyone?
3.
3. Derivative of dv by dx, right? So derivative of 3x is 3. Because x to the power 0, 1 minus 1. Right? So it is actually x to the power 1 minus 1. So that is x to the power 0. So it is 1 plus 0. Because O is a constant. So that we could say it is 3. So we found the dv by dx, du by dx. Now we can fill the blank. So we know that u is x square plus 1, right, into dv by dx. dv by dx is, we found that is 3 plus v, that is 3x plus 4 multiplied by du by dx. du by dx is 4. So that we could expand it, 3x square plus 3 plus 6x square plus 8x. So we can further solve it. That is equal. We can write it in a sequence. 9x square plus 8x plus 3. So that is your derivative dy by dx. Any questions? Any questions? Right. If you have, suppose, let's say, 3 components, y is equal u, v, w. If you have 3 multiple components, normally we don't use this in our studies, but if you have 3 multiple component multiplied, the derivative dy by dx is given as u into v into dw by dx plus u into w into dv by dx plus v into w into du by dx. This is how it goes. Right. Any questions? If not, we will have a break. Okay, we can continue. Madhavika, what is your chat information? Madhavika? (22,513). Madhavika, are you not around? Can you all hear me?
Yes, sir, we can.
Okay,
Yes, sir.
right. We can continue. Any questions on up to now about the rules? Any clarifications? Right. If not, then I couldn't remember the number. Rule number 6, y is equal u by v. Suppose, let's say, two components. I mean, function is given as two components. One is numerator, the other one is denominator, right? Numerator and denominator. How do you rate it, right? Yeah. So this is un v function. So let me carefully identify these two components, u component and the v component. So the derivative dy by dx is given as v into du by dx minus u into dv by dx, whole thing divided by v square. So this is the rule, right? If you identify numerator as the u, denominator as the v, then we apply numerator u and denominator v. Then the derivative is given as v into du by dx minus u into dv by dx, whole thing divided by v square. Right? Take an example, y equal, let's say 3x square plus 2x is the numerator, denominator 4x square plus 5 as an example, right? So we identify the two components, u and v. So numerator is identified as u, denominator is identified as v. So we could say u is 3x square plus 2x. Right? V is 4x square plus 5. So du by dx, as we already did, it's better to find out du by dx separately, then you fill the blank, right? 6x plus 2. If you do it quickly, then dv by dx is 8x. So we know now v du by dx, dv by dx. Now fill the blank. Now what does dy by dx says? V, that is 8x into du by dx. Sorry, I made a mistake. V is 4x square plus 5. That is your V into du by dx. What is du by dx? That is 6x plus 2 minus u, that is 3x square plus 2x into dv by dx, which is 8x. Right? Whole thing divided by v square, that is 4x square plus 5, whole thing square. Up to a certain level, we can solve this, not every. Suppose, let's say this is, if you expand this is 24x to the power 3 plus 8x square plus 30x plus, I'll write it still lower. Yes, 24x to the power 3 plus 8x square plus 30x plus 10 minus 24x to the power 3, okay, minus 16x square. I'm simply expanding it. I didn't do anything. 4x square plus 5, whole thing to the power 2. If you want, you can take that also out. All right. If you can expand it. Actually, if you give this answer at this level, if you give the answer at this level, that is fair enough. You don't need to solve further, right? Almost 90% marks will be given if you have this. If it is a complicated one, even 100 marks can be given directly. But if you can further elaborate, then you can elaborate, right? Right. Okay. Then this is what is that? 16x to the power 4 plus what is this 16x to the power? If you multiply 4x square plus 5 into 4x square plus 5, then you will 16x to the power 4. This is 20x square plus 20x square, 40x square plus 25. right? Okay. So we can, if you want, we can further solve it. So that is equal, this will cancel off. Then 16x square. Yeah. We'll end up with minus 8 square, right? Minus 30x minus 10. That is my numerator divided by, yeah, we can write it as it is. 16 x to the power 4 plus 40 x square plus 24. Okay. Right. Right. Any questions on that rule? Right. Let's talk about another example. Let's say y is equal 2 by x to the power. Look at here. Here you can work as this as u, this as v. But before that, you can think about what is in the numerator. What is in the numerator? What is in the numerator?
Constant.
Constant.
Yes, constant. So in the numerator, it is constant, so that we can we don't need to follow through that rule as we already defined, because we can rewrite this in a different way. So, for example, this can be written as 2 into x to the power minus 3 in a simple form. Right? 2 into x to the power 3 minus 3 in a simple form. Because otherwise, we'll have to use that rule, this particular rule. Is a long process. Still, you can get the same answer, no problem. All right? But the shortcut where we could rewrite it as y equal 2 into x to the power minus 3. So that my derivative dy by dx, as usual, minus 3 into 2 into x to the power minus 3 minus 1. So that is equal minus 6 into x to the power minus 4. So that we can write as minus 6 by x to the power 4. You see, in a couple of steps, we can complete it without much complication. All right? Any questions? Right. Then let's move to the next rule. I don't remember exactly what is the number. It's called as chain rule. It's called as chain rule. Right. What do you mean by chain rule? Suppose if a function has been defined by ux to the power n, the derivative dy by dx is given as n into a function of u as it is, right, to the power n minus 1 into the derivative of du by dx. So this is the chain rule says, right? chain rule says. Madhavika, are you around?
Sir,
Yeah.
Yes.
What did you ask from the chat?
sir, today there is a link shared with us. When go into today, it link to yesterday recording. I mean,
Yeah,
yesterday
but-
shared one.
Yeah, maybe today they will put the recordings.
Okay, sir.
Because
That
the
link,
same-
yeah.
Same link will be used to upload all the recordings. Maybe after weekend, you will get the recordings. That is how
Yeah.
it will be.
Yeah, okay.
I think so. I'm not sure. That is how they said. PGI will upload it either today or tomorrow, both
Yeah.
recordings. Yeah.
Okay, thank you, sir.
How about Professor Samita's recording? Was it there?
Yes, I got yesterday one, and it's still not received. No, it's still not received today's one, I think. So just
No. Yesterday's Professor Samita's one is there.
just wait a moment. I check it now.
No, I'm asking.
No, yes.
First
There's one
record-
also last week one. There's only last week one.
Yeah, that is what I am asking. Yes. Normally they upload it together. I mean, not only Professor Samita's one, my one also will be uploaded at the same time. If we
Yes.
are- yeah, that is why I'm checking.
Yeah, thank you, sir.
So they will upload it during the weekend. Yeah.
Yes, thank you, sir.
Right. Right. This is the chain rule. Right. Chain rule, where when you define the chain rule of the derivatives, you see n into the same function, then you have to the power n minus 1, right? N minus 1. Then you differentiate that component with respect to x. Right. We will look at this. An example, y equal x square plus 3x to the power 2. Right? Right? To the power 2. So that means you can use a chain rule here, or you can simply multiply them 3x square twice. Right? You can simply multiply x to the power 4 plus 3x to the power 4 6x to the power 4 plus 9x to the power 4 as an example, right? So this is you can expand it. For example, x to the power 4 plus 3x to the power 4, right? Then 6x to the power 4 plus 9x squared, isn't it? Am I right? Okay. So now you can differentiate in a normal way.
To the power 3.
Huh?
6x
yeah.
to the power 3.
Yes, this is not power, isn't it? I made a mistake. This is not square. Huh? I observed it. X to the power 4. This is also not power 4. This is 6x to the power 3 into 9x squared. Right? Yeah, I made it 9x squared. Right. Okay, now you can proceed to do the derivative of this. Suppose, let's say, if you have x square plus 3x to the power 5, you'll have to multiply 5 times, isn't it? You have to multiply 5 times. If it is 2 times, still you can do it. If it is 5 times, then you can. So that is why this chain rule is there. Right, we will take this example once again. Y is equal x square plus 3x to the power 2. So that is what I'm going to solve using the chain. Look at the template of the chain rule, right? dy by dx is given as. So you should identify this is u. This is n, right? That is equal n, which is 2 into your u, that is x square plus 3x to the power 2 minus 1. So that is the first step. Then you differentiate the component u. If you differentiate the component 2, that becomes as 2x plus 3. It becomes as 2x plus 3. This cannot be zoomed out. Somebody asked to zoom the screen. This cannot be zoomed because these are, I'm using a template, right? People are watching on mobile. I don't think you will be able to see all this. So I cannot zoom this, right? This is the standard software, I think. I cannot zoom. I'm not sure. If I try to click any of those buttons, maybe I will be lost. So I better not to. So this is all that I can help you. Zooming doesn't work in this pad, I think. This is a special software to write on the screen. Let me check. Yeah, let's see whether. Yeah, that is a magnifier. Magnifier doesn't work now. Other than that, zooming. I tried to zoom it, but it went off. Okay, we'll have to start the software again. I'll check whether. Yeah, that is all. I cannot zoom further. So that is the case. Right. What is the example that I had? Y is equal x square plus 3x whole thing to the power 2. right? Dy by dx is given as 2 into x square plus 3x whole thing to the power 2 minus 1 into derivative of that, that is u. That is 2x plus 3. So further, you can sort it out. That is equal 2 into x square plus 3x to the power 1 into 2x plus 3. So you could say 2 into, we could expand it further, 2x to the power 3 plus 3x square plus 6x square plus 9x. So this is 4. We can say 2x to the power 3 plus 9x square plus 9x. So that is equal 4x to the power 3 plus 18x square plus 18x. Right? So this is my final answer. So as I said, even if you stop with this answer, even you will get almost 90% of the marks. No problem. Right? Okay. Don't spend much time in solving this. First, you complete, even in the exam, if you complete this step, then you leave it and do the rest. Then you come back and solve it. Right? Okay. Because it takes time. If you do mistake, again, it will affect it. Right? Right. Let's practice a couple of examples on this chain rule. Right? Let's take y is equal x square plus 3x plus 2 to the power 4. Right? Can you do it? Can you do it? So here we have, this is u. U is x square plus 3x plus 2 is u. My n is 4. Right? So that is so we can differentiate dy by dx is equal 4 into x square plus 3x plus 2 to the power 4 minus 1 into derivative of that 2x plus 3. So that is equal 4 into x to the power 2 plus 3x plus 2 to the power 3, 2x plus 3. That is more than enough. This answer is more than enough even you get 100% of marks if you leave it here, because here the power 3 multiplicative is difficult. If you understand the concept, that is more than enough. Okay. Any questions? All right. Try this one.
Sir, excuse me, can you explain again how to get that derivative 2x plus 3?
Yeah.
Please explain again how to get that 2x plus 3, that derivative answer.
Yeah, this is very simple, isn't it? Is it, if you, because my u, what is my u? My u is 2x square plus, sorry, x square plus 3x plus 2. So what is du by dx? The derivative. Derivative of that is 2x plus 3. That is here. Right? So you differentiate what is inside that we have already considered as u. Right? So that is called as chain rule. It comes as a chain. First component and the second. Second component is the actual derivative of u. Because can you remember the rule when you say y is equal u to the ux to the power n? We said derivative is equal n into same component as the function to the power n minus 1 into du by dx. So the derivative of this will come. Okay. So, right, try this one. So n is minus 4. So we could say dy by dx minus 4 into x square plus 3x plus 2 to the power minus 4 minus 1, right, into the derivative of this component, that is 2x plus 3. So we could write it as minus 4, I mean, we could write it minus 4 into 2x plus 3, because it is with power 1, so that it is easy, into x square plus 3x plus 2 to the power minus 5. We could write it as minus 8x plus 12 divided by x square plus 3x plus 2 to the power minus 5. So this is the simple answer. Any questions on that?
So is that power minus 5 or plus 5?
Huh? Oh, sorry. Power 5. Not minus, yes. Right? Any clarification? Better to ask on the spot rather than referring it later. Anybody? Right. Can you try this one? Y equal 1 over, let's say x to the power 3 plus 3x square minus 6x plus. Try this one. Yeah, first step is you can write this as 3 x to the power 3 plus 3x square minus 4x, sorry, minus 6x plus 4, whole thing to the power, whole thing to the power
minus 1.
minus 1. Right. So that is your first step. Because otherwise, here we cannot consider this as u, this as v. Why? Because this is a constant. 1 is a constant. So no point of going for the numerator and the denominator function. So that what we could do is we could convert this into the minus power, right? Easily. Now we can proceed. Dy by dx is equal minus 1 to the power x to the power 3, sorry, minus 1 into x to the power 3 plus 3x square minus 6x plus 4 to the power minus 1 minus 1. Right? Further, to differentiate this component. So if you differentiate that component, this is 3x square plus 6x minus 6. Now you should be more efficient in doing derivatives after following the proof. Right. That is equal. So this is minus, right? X to the power 3 plus 3x square minus 6x plus 4 to the power minus 2 into 3x square plus 6x minus 6. So we could write it as minus 3x square plus 6x minus 6, whole thing divided by x to the power 3 plus 3x square minus 6x plus 4, whole thing to the power 2. So we can write it like that. Once you finish that, try this. Can you find out the derivative of that? Anyone? What is the answer? First, we'll have to convert it to the power. So how we can write this? This is 2 into x to the power 3, whole thing to the power 1 over 5. So that we can write it as 2 into x to the power 3 by 5. So that is your first step. Then you can do the differentiation. dy by dx is equal 3 by 5 into 2 into x to the power 3 by 5 minus 1. That is equal 6 by 5 into x to the power minus 2 by 5. So that we can write as 6 by 5x to the power 2 by 5. So that is your answer. Right. Try y is equal root of 3 x to the power 3 plus 3x plus 8. So your first step is you can write this as x to the power 3 plus 3x plus 8 whole thing to the power 1 over 3. From that you can proceed further. Right? Any questions? Any questions? Today, the number is less. Yesterday, it was like 130, 35 members. But suddenly, 20 numbers have been reduced. Any reasons for that?
Excuse me, sir.
Yeah.
So when our equation similar to u component, in the summation previously we got u as the x 2 into power plus 3x plus 2. Similar for first 3 equations. And in these equations, we take u as another way.
Where here? This one?
This one
Which
and
one? Which one you are talking about? This one?
Yeah. In here, yes. I'm talking about previous example when taking the answer. Not this is the last question we now need to solve. I'm questioning about previous one. In there, here also we take the our equation as a u component.
Yeah. This is again
thing
chain
is-
rule. This
No,
is
no,
a
thing is,
chain-
thing is for the previous example, we have missed the du divided by dx. We haven't do that second part, which means for the example, the last example, we need to do du divided by dx.
Which one? This one?
For the previous one.
This one? Are you talking about?
Yes. We only did the one part of the equation. The second part is missing. I think
What
that is why
second part is missing?
derivative of du. We didn't derive the equation.
When the starting chain rule in the lesson.
No. This is why chain rule.
Is this different one?
Can you cross check? This is the question, isn't it?
Yes. Then where is the u component here? We did it at u component x 3x2 power plus 3x plus 2.
Yeah, this is, you are asking this one, right?
Yes.
Wait. You all have complicated. Look at what is the difference. Look at this one. 2x to the power 3 by 5. Remember, I will show you. Right. Now, here we consider this as u, isn't it?
Yeah. Yes.
Now, look at u is a complex of group of members, right? Then only we need chain rule. Otherwise, we can do it directly. It is same as earlier one. Actually, this example is not within the chain rule. This is not within the chain rule. It is similar to 2x to the power 5. Did we use chain rule for this? Earlier, did we use the chain rule for that? No. Simply, what is the derivative of that? 10x to the power 4. Because it is only single member. Chain rule comes if the members are very long, more than one component. Look at it. That is why I said in the principle, you see, within that there is a function. X components are there in the functions. You see? Then only you can use the chain rule. Okay?
Yes.
So then only you can use the chain rule. For example, 2x square plus 8x to the power 5. Now, we'll have to use the chain rule, right? We'll have to use the chain rule. Suppose this is the case. Do we need to use the chain rule for the second one?
No.
No. Why?
Because we can solve it as
only one x component is there. Here we have a complex of x components. That is why we are using chain rule. So here, in this example, you see how many x components are there? How many x components? Only one x component.
Yes.
Right?
In earlier one, the 2x
which earlier one?
the line, yes, this one, yes,
above
this
or
middle
below?
one,
Above or
middle
below?
one, yes,
Huh?
this
one.
Yes.
This is a chain rule. This is a chain rule. Why? How many components are coming here?
3x.
Yeah, more than one, right? More than one. So this is totally different from this. So if it is a simple one, we can directly get the dy by dx. If it is a complex, a lot of components are there with the power. If there is no power, no problem. We can do it as normal. For example, if you don't have power, let's say y is equal x to the power 3 plus 3x square minus 6x plus 4. No power. In a normal way, we can do it. Dy by dx is equal 3x square plus 6x minus 6 in a normal way. As we did third or fourth rule, because only the additions are coming, additions and subtraction. If you take the power, then it comes as a chain rule. Because here, not only one component, there are so many x components are there. X to the power 2, x to the power 3, x to the power 1. Several components are there. Plus constant. So here we'll have to use the chain rule. Right? Even in this case, for example, here, right, my question is 2 to the power, sorry, 2 into x to the power 3 by 5. We simplify that. So x to the power 3 by 5. This is same as y is equal 2 to the power, sorry, 2x to the power 3 as an example. Only here the fraction is coming. So here n is 3 by 5, not 3, not 5. 3 by 5. Do you understand? So if you differentiate this, right? So dy by dx, the same rule, n that is 3 by 5 into c that is 2 into x to the power 3 by 5 minus 1. Got it? So then we solve it. So that is how it comes as 6 by 6 by 5 into x to the power 2 by 5. Clear? Okay? Okay. Got it? Everyone?
Yes, sir. Yes.
The chain rule is coming when you have power with so many components. Right? Not one component. Any questions? Whatever the method that you are using, here we have already differentiated. This has been already differentiated. This is the format of it. Okay. All right. Where are you? Yeah, this is the last example. This is a chain rule, definitely. Why? You see here the power is there for the whole group, not only for one. If it is only, as I said, x to the power 3, 3x plus 8, then no chain rule. Directly we can differentiate. When you get it with the power, whatever the power, it could be 2 or 3 or 5, for example. This is also chain rule. You can solve through chain rule. Right. Any further questions? Any questions? In addition to Madhavi, somebody also asked, did you understand? Somebody
Yes, sir.
also, yeah.
Yes, understood.
Got it? Got it? Yeah. So
Understood.
chain rule is coming when it's coming as a group. Then only we need to solve it, because we didn't. I mean, for example, if you differentiate this dy by dx, right? First, n into x square plus 3x plus 8 to the power 4. That's 5 minus 1. Okay. You see, sorry, not x square, x to the power 3. Yeah? X to the power 3. So here, it has been not differentiated yet. Did we already differentiate it yet? These individual components? Yes or no? Because
No.
x3 is coming as x3. Sorry, x to the power 3 is coming as x to the power 3. 3x is coming as 3x in the first step. 8 is coming as 8. So it has been, I mean, the component inside has been not gone through the derivative process or differentiation process. So that is why in the second step, we differentiating that component inside. Then that is goes as 3x to the power 2 plus 3. Got it? Okay. Is it clear now?
Okay, clear.
So,
Perfect.
so is this power is 3 or 5?
Here, this is 5.
Yeah.
No, I'm just, which one you are asking? This is power 5. This is 3.
Yes.
as an example, right? Don't worry about this power, but right. Right, now we are moving further. We are moving towards the sea. Earlier you were swimming at the bay or at the shore. Now you are moving towards the middle of the sea. That means it is more deeper. So now more techniques are coming, right? More differentiation techniques are coming. That you'll have to combine everything. Every rule comes and combine together. There's no such cases only applied with single rule. So, right, let's move to derivatives. Of derivative of logarithmic functions. Derivative of logarithmic functions. Right, maybe logarithmic functions, you might have learned some of these logarithmic functions. Log with the base a, when you multiply two functions, u and v, all right, that can be written as log with the same base a, u, plus log p with the same base a, right? This is nothing to do with derivatives, but you should know. If log of two functions together can be divided into different log forms and add together. Second one, log of the ratio between two components of a function can be written as log u with the same base a, log v with the same base a. The third one, log u to the power b with the base a can be written as b into log u with the same base a. So this is nothing to do with differentiation. It is some theory in our log functions. Any questions? This is nothing to do with us. It's maybe O level or even before that, you might have learned about it. Right?
Could you please scroll above
Yeah.
for the last last integration part?
Integration.
Sorry, last differentiation part.
This one? Huh?
Sir, in this case, if a number is arrives before x to the power 3 as a constant, what will happen? That will also multiplied in front of 5 as.
Wait. This one?
Yes, sir.
Right. So this is very simple. What is the function of constant early? What is the function of constant early? Constant will remain as it is.
Okay.
Right? X to the power 2 minus 1. When you say dy by dx, So constant will remain as it is. So here also 8 will remain. Then 5. Because it is multiplying,
Okay, sir. Thank you.
it is multiplying, not adding. It's multiplying. So that constant remain. So 8 into 5, then this component, then 5 minus 1, then you do the derivatives of this. Right? Right. So this is the log functions. Right. This is the rule. Y is log u. Derivative dy by du. Here we have u, right? Sorry. Dy by dx is given as 1 over u. This is the rule, huh? Into du by dx. This is the rule. If you want to differentiate y with respect to x, it will be written as 1 over u into du by dx. So this is the rule. Right. Now let's move. Y equal log x. Right. Remember, look at very carefully. Dy by dx is equal. Anyone? Tell me. 1 over u. Here, instead of u, what we have?
1 over x.
Yes, 1 over x. Because we replace u with x. So 1 over x into, what is next? Derivative of u. What is the derivative of x? 1. Anybody need clarification on that? Why derivative of x is 1? So this
Yes,
is
sir.
equal 1 over x.
Yes, sir.
Yeah? Yeah?
I didn't understand that, sir.
Why? That is the first rule, third rule. Y equal x. What is dy by dx? What is n here? What is n here?
1.
1. So I will use the rule 1 into x to the power 1 minus 1. So that we can write it as x to the power Nipunika. X to the
0.
power 0. What is x to the power 0?
1.
1. So derivative of x is, if I put it as 1, do you all accept it?
Yes, sir.
Right. Okay, so the answer, final answer for derivative of log x is equal 1 over x. Right. Let's look at a couple of more examples. Y equal log x squared. What is the derivative of that? We can do it two ways. Let's say dy by dx is equal. Now u is this. So what is that? Use the rule. 1 over anyone?
X square.
Yeah.
X square. Right. into du by dx, derivative of that. What is du by dx?
2x.
2x. Right. Now we can further solve it, isn't it? Because here 1x, 1x we can cancel off. 2 by x. That is your answer. Can you remember in the log transformation, we can write this as 2 into log x. Can I write it like this? Yes or no? According to this, the third way of writing. Can I write like this?
Yes.
Yes. Right. Now, I want to show you, we get the more or less, same answer if you convert it this. If you differentiate this, can you differentiate this? This is a constant, so 2 remains as it is. What is the derivative of log x? Anyone? You have to open your mouth.
X.
1 over x into derivative of this x, which is 1. So this is also 2 by x. So you see, same answer. Whether you convert it and do the derivation or directly will not make any differences. Here to everyone? Right. Take some more. Let's say log x square plus 1. Try this one. Anyone? What is the answer?
X over x squared plus 1.
2x. Once
Over
again,
x squared plus 1.
x square plus 1. Okay, let's do it. Right. So here 1 over x square plus 1 into differentiate that. Then that is 2x. So we can write that as 2x divided by x square plus 1. So this is correct. Another one. Anyone?
Eight x plus 12 over x squared plus 3x.
Once again.
8x plus 12 over x squared plus 3x.
Anybody? Anybody got the same answer?
Yes, sir.
Okay. Right, we'll do it. Right, dy by dx. Before we do the dy by dx, we can do it in both ways, but we can rewrite this as 4 into log x square plus 3x. We can write it like this. Okay, so if you differentiate this, that become as 4 into, sorry, 4, right? 4 is a constant, remain there, into 1 over x square plus 3x, right? Then you differentiate this component inside, that is 2x plus 3. So if you multiply that, that is 8x plus 12 by x square plus 3x. All right? All right. This is the simplest way. One way, I mean, normal way also you can do it. You can try as a homework, normal way, but you will end up with the same answer. But it is a long pathway, right? Long pathway. For example, without converting this, you can do the derivative. Yeah.
So here,
Yeah.
don't we need to use that power for in that when you 4 divide by 1 over x square?
Yeah, this is the 4. Yeah, we have taken that. No.
The power?
No, because I have converted this now. This log form, I have converted into this form.
Okay.
4 into log x square plus 3x. No more power is there.
Yeah, okay.
Right? No more power. Power has been dismantled. So that is the way that we can let it go. Right? So now it is no more power. Right. What about this? What is the answer?
X plus 2 over 4 x squared plus 4x.
Okay. So what is the first step? Log x square plus 4x to the power half. Very simple as earlier. So we can write it as half into log x square plus 4x. Simplify. Now if you take the derivative, so half is already there, which is a constant. 1 over x square plus 4x, right? Into derivative of that, 2x plus 4. So we can rewrite it as if you want, you can cancel off, otherwise 2x plus 4 divided by 2x square. Yeah, Ruben. Jerovan, can you mute it? 2x square plus 8x. If you want, you can cancel off 2 and so on, right? Right. Here you can take 2 out of it. X plus 2, sorry, x plus 2 divided by 2, x square plus 4x, right? 2 can cancel off, x plus 2 divided by x square plus 4x. You can write like this, right? No problem. All right. All right. Interestingly, y is equal log, let's say, x square plus 3x divided by 4x square plus 3. How to handle this? That is equal, can write it as earlier I said, log x square plus 3x minus log 4x square plus 3. Can we write like this? Can we write like this?
Yes.
Yes.
Yes. Now we can proceed in a simple way as we did already. If you say dy by dx, it is 1 over x square plus 3x into 2x plus 3 minus 1 over 4x square plus 3 into 8x. So that is equal 2x plus 3 divided by x square plus 3x minus 8x divided by 4x square plus 3. All right. Right. What is this? What is the derivative of that?
Zero.
Anyone else?
Zero.
Any other answers? Why 0?
It is the constant.
Yes, it's a constant. So derivative of log 40, here there is no variable involved. It's a constant. So it is 0. Right? Derivative of log 40 is 0 because no variable involved. Right. We move further. Exponential function. Derivative of exponential functions. Exponential function mean you might have seen this is called as e. Suppose let's say y is equal e to the power x as an example. This is an exponential function. What do you mean by this exponential function? For example, suppose let's say y is equal a to the power x. We can write this as if you take the log of y with the base a is equal x. This is similar to 100 is equal 10 to the power 2. right? So if you take the log 100 with the base 10 is equal to, right? Okay, isn't it? So log y is equal x. If you take the log, we can take it like this, right? So here, if you say log y with the base e is equal x, can I write like this? If I can write like that, I can do it. So this log e or log with the base e is called as ln, natural logarithm. Natural logarithm. It's called as ln. So what is the value for e? So e to the power x is given as the formula 1 plus x over factor 1 plus x square over factor 2 plus x to the power 3 over factor 3, and it goes like this. This is factorial. What do you mean by factorial? Factor 1 is 1. Factor 2 is 1 into 2. Factor 3 is 1 into 2 into 3. Right? So likewise it goes. So that we could say if e to the power, suppose let's say if x equal 1, so that means e to the power 1. What is the value for e? That is 1 plus 1 over 1 plus 1 over 2 plus 1 over 6 plus 1 over 24 and so on, so on, so on. So that the value actually, roughly, for the e to the power 1, it's given as 2.71828. It is a continuous, I mean, you get several digits. So if you stop at 5 decimals, it gives like that. Right, how to differentiate e functions? Y is equal e to the power x, right? So y is equal e to the power x, as we already said, log y, right, with the base e is x, so that we could write it as, how to differentiate log y? 1 over y into dy by dx is equal, you differentiate left side and the right side. So if you differentiate right side, it is equal 1. So we need in terms of dy by dx, that is equal, dy by dx is equal y. So what is y already? It is e to the power x. So dy by dx is e to the power x. Let's take another one. Y is equal e to the power 10x as an example, right? So log y with the base e is equal 10x, right? So that we could say 1 over y into dy by dx is equal, so that is equal, so dy by dx is equal 10y. So we know the value of y, so that 10 into e to the power 10x. Right, we can follow a rule. Now another rule coming. Suppose, let's say, if y is equal e to the power u, the derivative is given as dy by dx is equal e to the power u into du by dx. So this is the rule. This is the rule. Suppose, let's say, if I have y is equal e to the power 3x, right? Dy by dx is given as you write the exponential function as it is into the derivative of that component, which is 3. So 3 into e to the power 3x. Right? So similarly, y is equal e to the power 4x to the power 3. Right? So dy by dx can be given as e to the power 4x to the power 3 into the derivative of that, which is 12x to the power 2. So we could say that is equal 12x squared e to the power 4x to the power 3. Any questions? Any questions on exponential function? Yeah. Right. How to handle some of the exponential functions? Let's say y is equal further e to the power 3x squared plus 2x. So dy by dx is e to the power 3x squared plus 2x. Then differentiate this component, that is 6x plus 2. So we could write it as 6x plus 2 into e to the power 3x squared plus 2x. That is my answer. Right? Similarly, y is equal x to the power x. So here, if you take log y, that is equal log, take log, because both are variables. Take log function x to the power x. So we could say this, we can write it as, right? Log y is equal log x to the power x. This we can further write it as x into log x. So if you differentiate, this is 1 over y into dy by dx is equal. Now if you differentiate, this is u component, this is v component, which we have studied earlier. Multiplicative function. So if you differentiate that, u into dv by dx plus v into v is log x into du by dx, this is 1. So that is equal, here this is 1 plus log x, right? So dy by dx is equal y into 1 plus log x. So we know y is already, y is equal x to the power x, so x to the power x into 1 plus log x. Clear? Any questions? I'll put up some examples. Maybe next time we can try all these examples. Y equal a to the power x, y equal a to the power x to the power 3. Some examples, right? You can do it as a homework. y equal log 1 over x right? You can try all this as example. We will do further some examples. Right? Take another one. Y is equal 1 over x into ln x. Ln x also there's a slight differences in differentiation, but don't worry. You
Hello.
do it as a differentiation. Right? So y is equal ln x. This is also same as dy by dx, same as the log function 1 over x. Right? So ln x or log x, consider it as the same, but there's a slight difference, but don't worry. We don't want that. There's a small adjustments. Right. I think for the time being, that's all. We will go for the quiz. Everyone, as I said earlier, please answer the quiz to the chat. Right? Don't answer, don't attach any attachments, and don't send any emails. So these are quiz. Will be given maximum of 10 minutes. You can type the quiz, answers on the chat. Let me check the chat. Yes. Neither question. Find the equation of the perpendicular line to 2x minus 3y equal 9 and passes through point 4n minus 1. So this is the question. Find the equation of the perpendicular line to 2x minus 3y equal 9 and passes through point 4n minus 1. Okay, carry on. අම්මාට කළොත් අම්මා 3 minutes more. Okay, time is up. I'm going to wind up maybe a couple of seconds more. Okay, see you. Bye next week.